I'm sure that by now you've heard of some version of greenhouse gases, the carbon cycle, and climate change. But how are they all really connected? Well, to understand that, it's critical to first understand a graph with an increasing pattern known as the Keeling curve. It all starts at the top of a volcano in Waimea, Hawaii. Though it sounds like an exciting vacation destination, a scientist named Charles Keeling had a different plan. In 1958, he conducted an experiment proving that our carbon emissions are almost entirely responsible for climate change. Now, what he found is considered to be the base of all climate change research. But before we get into that, let's take a closer look at that carbon. Carbon dioxide is a greenhouse gas, or a gas that traps heat in the Earth's system, just as a greenhouse would to plants. Carbon is in essentially everything, and that's natural, but it's what we do with all that carbon that impacts our climate. Most of the CO2 in our atmosphere is emitted by the burning of fossil fuels, which is really just big chunks of carbon, so that it can be used to turn on the lights in your house or run your gas-fueled car. Now, our individual actions aren't really what's making our climate hotter, but as a whole, with every person that drives a car and every person that owns a house with electricity and ventilation systems, the carbon emissions become so large that it imbalances the natural cycle, which systems through all four of Earth's spheres, from the atmosphere to the biosphere to the hydrosphere and finally the lithosphere. So, all in all, carbon dioxide is pretty much the foundation of climate change. Now, this is where the Keeling curve steps in. See, none of this really would have been discovered without Keeling's experiment. After beginning the research in 1958, Keeling's machines on top of the Mauna Loa volcano took daily measurements of the atmospheric CO2 and created a graph comparing it to the Earth's climate. This graph is famously known as, you guessed it, the Keeling curve. Through this experiment, Keeling not only discovered an annual increase of CO2, but also a seasonal pattern. In the spring, atmospheric CO2 decreased as plants absorbed it into the process of photosynthesis, and in the fall, it increased as these plants die and release this carbon back into the atmosphere. Okay, so now we know what the Keeling curve is, but why is it so important anyway? Well, without the Keeling curve and the discovery of the relation between our carbon emissions and climate change, we wouldn't have the information we need to recognize the impact our actions have on the Earth and its climate, and how we can reduce those impacts. So next time you leave the shower running before you get in, or run the dishwasher with only a few plates, remember the Keeling curve and how your actions will impact it. Thanks for listening.